Hi.
Hey Yakov, how you doing?
Good. Good. How are you?
Yeah, pretty good, thanks. Pretty good. Here's Rob too. Hey Rob.
Hey guys.
Hey.
Yeah, I saw your note that you might have to drop off.
Yes.
Um, all right. Why don't we just get started and see how far we can get? If that's okay with
Absolutely.
you? Or
Yeah, let's do that. Uh, I'm not able to share my screen, so we'll have to just do this by voice. Anyway, yeah. Okay, cool. So I have raised a new pull request just in draft form for review that implements, or I believe it implements the new uh, incremental delivery format or the latest version of that. Um, Sorry, this meeting conflicts with another one. I just was sending an apologies to that. So one of the main issues that I had with the previous implementations or the previous specifications of the stream and defer was that they had a lot of state management that we don't generally have as part of the GraphQL spec. There was a lot of like tracking and undoing of things. Um, and generally, we don't have that problem in the GraphQL spec because it works in more of a functional style. So things don't tend to have side effects. The data just sort of flows down. There is exception handling, and that's broadly how any issues with side effects would normally be handled. And so my aim was to make it so that the stream and defer would also work in the same manner. So generally, it would be functional style. Data would just flow down through naturally. And then if needed, there would be some form of exception handling that would just catch any issues and wouldn't need to undo anything because effectively no data would have been returned in the first place. So in order to do that, what I've effectively done is broadly similar to what I had proposed a year and a bit ago with the delivery groups, i.e., at field collection time, we choose the things that need to be executed now, and we also track the things that need to be executed next. And then what we actually do is we turn the incremental delivery into effectively a series of streams. So we group things together that overlap and execute those through one stream, and through the other things that don't overlap, we do in separate streams, which we can run in parallel. And effectively, when those streams resolve with data, we can send that data through to the client. Um, One issue that comes out of this is that effectively, if you have overlapping defers, then their common bits would be, according to the spec, would be evaluated first, and then um, those remaining parts would break off into separate streams. Whichever of those then remaining streams would return the data first would also have that common data prefixed, I guess, would be one way of describing it as it goes down through. There's also algorithms in there for like merging together multiple payloads so that we don't have to send thousands of payloads. We can send one payload with thousands of entries, that kind of thing. But basically, it implements the response format that we described in a functional manner without needing any like state management and stuff. And as compared to at least my previous proposals, it's much, much easier to understand how through a implementation, you might go ahead and do early execution of various things. Effectively, you can do it at field collection time and effectively memorize it. So you'd, or not memorize it, that's not the right word, but like cache it. So when it comes time to send that response according to the actual algorithm, turns out you've already calculated it. So you just would send it at that point. You'd also need to cache errors and things like that and only throw the error when that point occurs. But yeah, broadly, I think it does it pretty well. I'm reasonably happy with it. Unlike my previous solution.
Yeah, thanks a lot for taking the time to put this together. I still need to spend some time reading through it to make sure that I fully understand everything that's going on. Any other specific parts you want to call out?
Well, there's no text really that goes with it. And in fact, the text parts of it, I'm not sure are correct because honestly, I haven't actually gone through and rewritten the text. All I focused on this time was the algorithms. So focus on the algorithms, ignore the text, that will come. And then a lot of the text needs to come over from your original pull request as well, because this was just an exploration of what the algorithm could be, another form for that solves the issues I previously introduced. Also in the pull request, just in case it's useful for anyone, I've kind of described the various algorithms as like TypeScript functions, as you can see there. That's not meaningful. It's just a useful, handy reference because we're talking about like field collection as field digests now. So it helps you to keep in mind that there's the selection and also the delivery group that goes with it and various other things. So you can see what the types are of the things. I mostly used it to help myself keep track of what we were actually talking about as I went through and wrote it.
Yeah, awesome. Definitely very helpful. So this does still have path as an argument to collect fields, which would break the memoization that happens in GraphQL JS at least. Do you have like an idea of like working around that, or?
Yeah, I think GraphQL.js would break collect fields up into two halves. So effectively, it would do a memoizable version, and then it would just collect the results of that along with the runtime path. So effectively, every call to collect fields will return effectively the same data. It's just the field digest will have a slightly different delivery group in it potentially, especially when it comes to stream, I think. So the selections themselves could be cached. The delivery groups would be derivative or not. I think it's solvable, but I'd have to actually be in the JavaScript and write that.
Yeah.
Yeah.
Okay. And where does the stream happen?
So it all comes out of the incremental event stream algorithm. So effectively, what I had before, I'm not sure if you remember, but I had a massive function with a whole bunch of what I called like sub procedures or something like that, macros effectively. Yeah. I have broken those out into separate algorithms now because they don't have like a shared state or shared variables or anything like that. They don't need to undo any of that state anymore. So it's now just traditional algorithms. But that incremental event stream effectively sends the original response, the data errors and pending, to the client. And then it sets up a bunch of streams to do any of the incrementals. And then those streams can set up their own streams and so on. And so it's effectively like nested streams. And that was really the breakthrough that I had in this was if we model it all as streams, then all of the rest of the behavior just flows out of them very naturally, which was quite nice.
This incremental event stream, that is that called when at like the top level of the when it's executing the whole operation after
Yes,
you've already
exactly that.
done um
So we
so
abstracted in a separate branch, we've refactored how execute query, execute mutation, and subscribe work so
right.
that they all call the execute root selection set. And then that execute root selection set basically says, if there isn't anything that is incremental, then just do what I always would have done and send the data and errors. Otherwise, do the incremental event stream. It's line 350 if you're looking for it.
I'm just looking through at the types right now.
Oh, right. Yeah.
Um
So it would be from the execute root selection set that would call incremental event
and
stream.
execute group field set, that's called at every level, right? And that's
Yeah.
where now you're returning not just the result map, but the result map and the incremental details, and then the incremental details is that's what gets assembled into the event stream.
Effectively, yes. That stuff will be grouped together and then turned into streams. And of course, if the execution of the field set explodes for whatever reason, for a null happening in a non-null, then those incremental details by path will also naturally explode next to it. So they'll never be collected. So they'll never trigger any async work.
Do you have like a data structure where all of the fields that need to be executed are organized as like a tree? Is that how you know the right order to
Yeah, I think what
get it
you're
in?
thinking about is probably the collect delivery groups.
Okay. So how does your algorithm know like when you have like the overlapping fields that the fields that are overlapping have to be executed before the ones that aren't overlapping? That's what you were saying before, right?
Yeah, yeah, definitely. It does know that. Bear with me whilst I figure out how. Right, there's an algorithm called partition delivery group sets that effectively, well, partitions them. It finds the ones that are overlapped with each other. It effectively does a little bit of graph theory. So it puts all of the delivery groups onto a graph, connects them based on their dependencies with each other, and then finds the separate subgraphs. So it finds the separate bits that are connected. If there's no connection between two things, then they can run in parallel.
Okay. And now, like, once you figured out this graph, that basically gets built all the way up to back up to execute root selection set. And then is that what gets passed to incremental event stream?
No, incremental event stream is sent effectively the result. You remember how collect fields returns both the result set and like the incremental
Yeah.
things. Those are grouped together, and that information gets passed into the incremental event stream. And then incremental event stream itself takes care of doing the partitioning of the delivery groups, because that's something that has to happen in a recursive manner. Because then each child incremental stream needs to do its own grouping by whatever the next level of defers are. It's effectively a recursive process in the same way that the execution in GraphQL currently is a recursive process.
Okay, I think I understand. Um, these changes is only defer, or there's a stream in here too?
Currently, it's only defer, but I don't think
Okay.
it would take a huge amount to change it for stream. I just thought since we
Yeah.
decided that getting defer out would be better, I'd only focus on that.
Yeah, sounds good. I definitely want to spend some more time with this, and I'll try to do that this week.
Benji, quick question. Could you highlight, I think in one of your comments you had written out, but maybe you could highlight now where early execution would come into play, like where exactly you might drop a node in, for example.
Yeah, okay. So I mean, as an implementation, you've got a lot of choices of when to do this. But when you do, I think it's complete value. Hang on just a second whilst I track through this. Yeah, when you do complete value, you split the result set into the stuff that you've executed now and the stuff that you're going to execute in future. If you wanted to, at that point, you could effectively execute the future things anyway, and just attach them to something that, cache them effectively. So then later, when the algorithm says to execute them, you would just use that cached result, whether it be an actual result or an error.
Do you handle the errors? And you handle the errors at that point then when you're in incremental event stream?
Yeah, the handling of the errors works very similarly to how it does for the regular GraphQL execution algorithm. It's just this time we're handling errors that were thrown from streams rather than errors that were thrown from resolvers, I guess.
Yeah, I mean, just thinking about early execution, like if you had everything the same, but instead of executing at the end after that stuff is done, but you executed up front and held on to the result and the errors, like I'm wondering, like, would the logic be the same where you see that this has the error now, and then maybe other stuff is already executed that you don't need anymore, but you wouldn't need to traverse down that tree any further once you see that there is an error?
I guess you could do that as an optimization, but you probably need to be a bit smarter about it because obviously there's more error boundaries in this situation. It might be parallel defers where one of them's going to blow up, but the other one isn't, and things like that.
Mhm.
So yeah, I'm not sure you'd be able to. Well, you'd definitely be able to if you wanted to put enough code into it. I don't think it'd be worth the effort to necessarily prevent some of the execution there.
Sort of similar to how GraphQL JS doesn't cancel promises. Is that sort of what you mean? Like not worth it?
Yeah, I mean, what GraphQL.js does is when it's executing a selection set, if an error happens, then it just stops executing the rest of the selection set. It doesn't like proactively, I don't know, I don't even know what to say there. And similarly, like if an error is thrown during this algorithm, it just stops executing the rest of the algorithm. And that's fine. With there isn't anything in GraphQL.js where it does premature execution of things. So there is no like looking ahead, I guess, to see if we know that this thing is going to have errored.
Yeah, I mean, in the synchronous code, it'll obviously stop everything, but then you have promises that could run for a while.
Yeah.
I mean, I tell you that I have to look at it more, but the huge positives that I see in these changes, first of all, is their overall simplicity. I like the use of the delivery groups without really tracking intermediate state, and I kind of love the fact that the initial non-defer version is kind of still presented as the default. And well, I love part of that. In that like if you're the original GraphQL.js pre-incremental delivery is sort of essentially unchanged. Um, the the parts that I'm less excited about are the just really the note that I raised about the sequence of execution of sibling defers where some of them overlap and some of them are unique. And we sort of chatted about that on the issue or the PR, I guess. But so I sort of see where you're coming from. You could always execute those early. I just think the spec itself, it would be great if it was written in a way that everything that sort of ideally would be executed in parallel through like the intended use of defer like was executed in parallel, like actually in the spec. And then Rob did mention that it would be great, I think, if collect. I'm not. I mean, I think it would be great, but I could see why others would disagree that if collect fields didn't take a path just in general, because I think because when once collect fields takes a path, it sort of it makes it difficult to see how easily it can be memoized, um, and like persisted across for a list and also persisted across operations. Um, and the third thing is that I would love to see like how I would love to see like a version of early execution in the spec. I mean, basically what I've been working on in the PR that I was working on is sort of like a one-line difference between early execution and delayed execution. And obviously that comes with its own trade-offs, some of which you've avoided. So I sort of see the benefit of your choices here. Yeah, but I think it's a really great effort, and I'm still working on it, working on reading through it.
Awesome. Thanks, Yakov. Well, so the two main comments there that I pulled out were the uh, memoization of collect fields, which I definitely think that's effectively an optimization that we can address in spec text. I'm not 100% certain how we would do that currently, but I'm pretty sure we could, right? Because it's going to give you the same kind of result each time. We do need path associated with certain things, but we can do that in a separate layer. So it could be that, like, for example, you collect fields and store that into one key in an object, which then also has the path next to it or something like that. And that would probably be all the information we need. So it'd be a little bit of restructuring, but broadly similar. The other concern, and this is a very sensible and reasonable concern. So we talk about early execution. But I want to differentiate, as you have done, but just to highlight this, we effectively have the execution that my algorithm does currently. We have the fact that when defers overlap, you would probably desire to run all of the fields in those defers in parallel, which isn't really early execution, but it is, according to my algorithm, it would be executing it earlier than it would be executed by the algorithm. And then you have the other form of true early execution, which is where you just do things as early as you can. Anyway, just kick it all off, and then hope that it's ready by the time you come to need it. So yeah, I get the concern there, and you could certainly write GraphQL queries that would make this very stretched out. So writing a whole bunch of fragments that are all deferred and that all overlap by one field and then another set of fragments, which would make layer upon layer upon layer upon layer of these delivery groups, I guess. And that is one of the weaknesses of this, I think, but also addressing that in spec text, I'm not convinced that we necessarily need to. I think we can, with a note, acknowledge that this basic algorithm has this problem and suggest that the way to go about solving that would be to introduce a cache and execute the things that are in this set all in parallel, and then just cache the ones that aren't needed right now, or some wording similar to that, rather than actually complicating the algorithm. Because, or at least I haven't managed to come up with a way of writing an algorithm that handles that doesn't massively increase the number of lines of spec text. And I think fewer lines of spec text is generally better.
Yeah. I mean, so basically what I've been doing is coming from the over, I guess, I don't know how long it's been now, but coming from the other the end of it, I've been working from the implementation so that we have up for a while now. And I've been basically I started basically like a line by line translation of that into spec text. And I've been slowly paring it down as best as I could to sort of decrease the size. So so what I have in basically, so I just submitted, like, obviously no one looked at it. I barely looked through all of it, but about 2 minutes before the start of the meeting, I introduced the further pared down version. So I would just and basically only the last commit in that spec, it's building on it's like the common changes that have been extracted, and then moving field collection around a little bit, and then just adding text about async streams just in general. But so the last commit is really the only commit that it that introduces incremental delivery, and it's got what looks like 533 lines in it. And I'm just looking right now. The version you have here was very nicely pared down. And if I look at like its last commit, or I'm not sure if I should look at its last commit. Yeah, no, I can look at all of them because you're merging it into the other version. So I think what you have here is 373. So that's a difference, right? I'm not sure. I'm not sure for me if that meaning yours is shorter, and let's say yours doesn't have stream in it. So I don't know, we could round up to like 400. So we are talking about a difference of like 100 plus lines at least. But I think overall, like I think I would be more comfortable like just keep going in terms of pairing and optimizing and simplifying, but having the spec text actually directly provide the algorithm that that defers only what's we want to be deferred. So that's like overall and the other two differences were basically the points I made. Like we have in that algorithm like a memoized version of collect field slash field group set partitioning, field plan building, whatever you want to call it. So we have that part done already. So that so that's sort of, I think, proof that you could add that to your algorithm. And it's certainly doable. Like you said, you think it's doable. I think it's definitely doable. But maybe it requires like a couple hundred lines. That again like narrows the sort of the difference in like size of the spec edits. So yeah, so I think it's possible. So and I would push for it, and like to just keep going in terms of simplification.
Awesome. Well, it's great, I think, when things start to align, and attacking a problem from two different sides is an excellent approach. Should hopefully meet in the middle.
Yeah, yeah.
Awesome. This meeting actually conflicts with another meeting for me. So if we don't need to discuss anything else, I should probably hop off and go on to my other meeting.
Yeah, sounds good. Thanks a lot for taking the time to go through all this. I'm going to spend a lot more time reading through it this week, hopefully. And I mean, I think generally, I feel like we should just get to a set of spec edits that me, you, Yakov, all of us in this group are happy with, and then come up with a plan of like how to bring it to the rest of the TSE and working group.
Yeah, sounds great. Awesome.
Yeah, thank you so much, Benji, for sharing and going
thanks a
through it
lot.
with us. Thanks.
Yeah, you're very welcome. All right, thanks everyone, and talk to you again soon.
Yeah, does anyone else have anything they want to bring up, or otherwise next meeting is March 11th, I think. All right. See you all then. Bye.
Bye.